I think we are live. Guys, am I audible to you? Am I audible to every one of you? Yes. Let me know in the chats if I'm audible to you properly. Let me know in the chats if I'm audible to every one of you. Just give me a second, we shall be starting. Let me fix certain things. Just a second, guys. All right, so good evening all my lovely students. Good evening. I welcome you all again back to your Vedantu and Lead channel. I hope you all are doing great, having a good time. So people, quickly give me some green signal from the chat so that I'll get to know I'm perfectly audible and visible to every one of you. Yeah? Give me some green signal from the chats. Hello Shruti. Hello Keshav. Hello Carol Islam. Hello Yazini. Welcome back everyone, welcome back. Just give me some green signal, people, from the chat so that I'll get to know I'm perfectly audible and visible to every one of you. Yes? Perfect. All right, so just give me a second. We shall be starting, yeah? Just give me a second. All right, so people, as you all must be knowing, tonight it's going to be our second block of the IDOC series, right? In the first block, we did some chapters from your inorganic chemistry, like your chemical bonding, periodic classification, right? Coordination chemistry, S block, P block, etc. In the tonight's session, which is basically our second block of this IDOC series, we shall be discussing few scoring chapters and important chapters of your physical chemistry. So the chapters which I'm going to do in the tonight's session, it's going to be thermodynamics, chemical equilibrium, ionic equilibrium, chemical kinetics, and electrochemistry, right? Well, the set of questions which I have come up with in the tonight's session, let me tell you, by solving these questions, all the concepts about these chapters, I'm sure they will get properly clear to you. And you'll get the idea of different types of questions which can be asked in your upcoming NEET 2022 examination. Perfect. So before starting this particular session, the ones who have just joined in, the ones who are new to the channel, I'll just quickly introduce myself. So people, my name is Wasim Bhatt, and I'm your chemistry master teacher right here on this Vedantu and Lead channel, right? Well, the ones who have not liked the video yet, please do like the video, share the video with all of your friends, do subscribe to the channel, and do not forget to hit the bell icon as well, right? So do like the video, share the video with all of your friends, and do subscribe to this particular channel as well, right? Perfect. So you guys can quickly let me know in the chats if all of you are super duper excited about this particular session, my dear people, right? You guys can quickly let me know in the chats if all of you are super duper excited about this particular session. Yes? Let me quickly know in the chats. Well, we shall be starting with the concepts of chemical equilibrium, then we'll go to ionic, then we shall be going to chemical kinetics, right? And similarly, we can go to other chapters like thermodynamics, etc., right? Let me know quickly in the chats, people, if all of you are super duper excited about this particular session as well, right? Perfect. Should we start the session? Should we start the session? Perfect, guys. Perfect. So let's get going then. Let's get started with the chapter chemical equilibrium with the first concept, first question, which is on your screen, right? Well, the question says, write the expression of Kp in terms of Kc, right, people? So this particular question will just teach you one concept. What is that going to be? Have a look. Have a look at exactly what I'm going to do. Well, people, I'm sure you must have studied one relation like this. Kp is equal to Kc RT raised to the power delta N, right? This is something which I'm sure everyone would have studied. Perfect. This is the relation between your Kp and Kc, which I'm writing over here. Now, first thing, we need to write the value of Kp in terms of Kc for every reaction that is given to us, right? what I'll be exactly doing. For example, you have got the first reaction, my dear people. In the first reaction, what I shall be doing, I will be first of all calculating the value of delta Ng for the first reaction. Well, if I ask you how to calculate delta Ng, it's nothing. It is just number of moles of gaseous products minus number of moles of gaseous reactants, right? Well, I forgot to tell you, the session duration will be around 2 to 2.5 hours, right? Because we have got a lot of questions to discuss in the night session, so it will approximately exceed 2.5 hours, right? Perfect. All right, so delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. So first of all, if I ask you, in the first reaction, how many moles of gaseous products we have? We have got 2 moles of gaseous products minus how many moles of gaseous reactants do we have? See, this is in gaseous phase, this is in gaseous phase. Its stoichiometric coefficient is 1, its stoichiometric coefficient is 1, so 1 plus 1 comes out to be 2. So 2 minus 2 comes out to be 0, right? So I got to know for the first reaction, delta Ng is equal to 0. If delta Ng is equal to 0, this becomes RT raised power 0 and anything raised power 0 is 1. So for the first reaction, you got to know exactly Kp is equal to Kc. So this is the relation between Kp and Kc for the first reaction, right? If you look at the second reaction, my dear people, look at the second reaction. Again, calculate delta Ng for the second reaction. It's going to be very simple. Number of moles of gaseous products, which is again 1 plus 1, that comes out to be 2, minus number of moles of gaseous reactants, that's 1. The value comes out to be 1 over here, right? Well, you got to know the delta Ng value. If you got the delta Ng value, you can write the expression of Kp in terms of Kc. You can write Kp is equal to Kc, RT raised by delta N, that is 1. So this is the relation between Kp and Kc for the second reaction, as simple as that. Well, people, if you look at the third reaction, for the third reaction, let's calculate delta Ng again. Well, you know, in order to calculate delta Ng, you only need the gaseous reactants and products, right? See, delta Ng for the third reaction, number of moles of gaseous products, that's 2, minus number of moles of gaseous reactants, that's 1 plus 3, that comes out to be 4. So 2 minus 4 comes out to be minus 2. So you got the value of delta Ng, right? Now you can write the Kp in terms of Kc. It's going to be Kp is equal to Kc, RT raised to the power delta N, which is minus 2 in the third reaction. So this is the relation between Kp and Kc. And similarly, you can calculate the delta Ng for the next reaction as well. It's going to be number of moles of gaseous products. That's going to be only 1 because this is in solid form. This is in solid form. You do not have to take them, right? So delta Ng is equal to number of moles of gaseous products. That's 1 only. 1 minus 0 comes out to be 1. And eventually, you can write Kp expression in terms of Kc. As simple as that, right? So this is how you can solve this sort of equation, very simple and basic question, which I had come up with in the beginning, right? Perfect, number 1. Is it clear, guys? Let me know in the chats. I'm sure this is damn clear to everyone. All right, look at the second type of the question, which will make you understand one more concept, right? And I'm sure you guys will be remembering them from now on. Have a look, guys. Kp for the reaction. Since we are given with a reaction whose Kp value is given to us as 49, now we are given with one more reaction and we are supposed to calculate the Kp for this particular reaction, right? The second reaction which we are given with, we need to calculate its Kp. How do we approach this sort of a question? Do remember, the reaction for which you need to calculate equilibrium constant, you will be trying to make this particular reaction out of the given reaction. Right? You need to make this particular reaction out of the given reaction. What is my given reaction? What is the reaction whose Kp value is given to me? It is N2 gas plus 3 times H2 gas. It is basically in equilibrium with 2 times NH3 gas. This is the reaction that's given to me and its Kp value is given to me as 49. Now, I'll be doing certain manipulations, right? I'll try to make this particular reaction out of this reaction. And how do I do that? Have a look. First thing which I'll be doing, my dear people, I'll be just reversing the reaction. If I reverse this particular reaction, it's going to be like this. 2 times NH3, it gives N2 plus 3 times H2. And do remember, when you reverse the reaction, which will be at equilibrium, when you reverse the reaction, its equilibrium constant is inversed basically. Equilibrium constant for the first reaction was 49. Now the new equilibrium constant for this particular reaction after reversing becomes 1 by 49, number 1. Number 2. Now I'll be multiplying this particular reaction with the number 1 by 2. If I multiply this particular reaction with the number 1 by 2, this becomes simply NH3 in equilibrium with half of N2 plus 3 by 2 times H2. Since I multiplied this particular reaction by 1 by 2, that 1 by 2 will be going to the power of the equilibrium constant. So it becomes 1 by 49 raised to the power 1 by 2. So the value comes out to be 1 by 7, right? Now people, this was the reaction for which Kp value was supposed to get calculated, right? And we made the reaction and we got to know its Kp value is coming out to be 1 by 7 over here, right? I'm sure this concept is again clear to every one of you. Perfect? Yes, so one more concept cleared. Moving on to one more question. Look at this particular question, guys. Have a look exactly what I'm going to talk about. For the reaction, we are given with a reaction, and the reaction is something like this. Have a look. The reaction is A gas plus B gas. It's in equilibrium with 2 times C gas. This is the reaction that's given to us, right? 2 moles of A, 1 mole of B, and 1 mole of C are placed in a 10 liter of vessel. So basically, this reaction will be taking place in a container whose volume is going to be 10 liters, right? Now, at time t is equal to 0 initially, as far as the question is concerned, we are starting with 2 moles of A, 1 mole of B, and 1 mole of C. So initially in the container, you will find some 2 moles of A, 1 mole of B, and 1 mole of C in the container whose volume is 10 liters, right? Now, as far as the question is concerned, now the reaction will start, and after some point of time, you'll find equilibrium will be established in the reaction, right? And when equilibrium is established in the reaction, the concentration of C, final concentration of C means concentration of C at equilibrium, right? It's given to me as 0.2 molar. Concentration of C at equilibrium is given to me as 0.2 molar. What do I need to calculate? I need to calculate the value of Kc, right? Yes, I need to calculate the value of Kc. Now, exactly how am I going to calculate the value of Kc over here? Have a look, people. Let me assume at equilibrium, out of 2 moles of A, there are some X moles of A which have reacted with B, right? If out of 2 moles of A, X moles of A have reacted with B, I must say there will be some 2 minus X moles of A still left in the container at equilibrium, right? Now, I'll say 1 mole of A reacts with 1 mole of B as per stoichiometry. So X moles of A would have definitely reacted with X moles of B. Initially, I had some 1 mole of B, and we got to know out of 1 mole, there are some X moles of B which have reacted. So I'll be left with 1 minus X moles of B at equilibrium, right? In the similar way, my dear people, in the container already there was 1 mole of C. Now, since the reaction has proceeded, so there will be some extra moles of C which would have got formed. And now, have a look. I'll say 1 mole of A gives 2 moles of C. So from X moles of A, you'll be getting some new 2X moles of C, right? So these are the total moles of C present in the container at equilibrium, right? So basically, you got to know the moles of each reactant and product present in the container at equilibrium. Perfect. But in order to calculate Kc, do I need to calculate the moles of reactants and products at equilibrium? No. What do we need then? We need the concentration of each reactant and product at equilibrium. How do you convert these moles into the concentration? You are simply supposed to divide these moles by the volume of the system, which is given to me as 10 liters, right? So I'll be dividing this term with 10, this term with 10, this term with 10 liters, right? So basically, I got the concentration of each reactant and product in the container at equilibrium, right? Perfect. Now, people, as far as the question is concerned, concentration of C at equilibrium is 0.2 molar. And we got to know the concentration of C at equilibrium is basically 1 plus 2x divided by 10. So this value is basically equal to 0.2, which comes out to be 2 by 10. So 10 cancel. So 2x value will be equal to 1 and x value will be equal to 0.5, right? So you got to know the value of x exactly. Since you got to know the value of x, so you can put the value of x into these expressions over here, and you'll be getting to know the exact concentrations of reactants and products. So this is going to be 2 minus 0.5. That is 1.5. 1.5 divided by 10, which is 0.15 molar. So this is the actual concentration of A in the container at equilibrium. In the similar way, 1 minus x by 10. 1 minus 0.5 is 0.5. 0.5 divided by 10 is 0.05 molar. This is the concentration of B in the container at equilibrium. And 1 plus 2x by 10. 1 plus 2x divided by 10. This value is already equal to 2 by 10. That means 0.2. So this value is equal to 0.2. So this is the concentration of C in the container at equilibrium. Since you got the concentration of each reactant and product in the container at equilibrium, you can easily write the expression for Kc now, right? That's something which you were supposed to calculate. Kc expression, how do we write? We start with the products. I'll write concentration of C present in the container at equilibrium raised to the power of stoichiometric coefficient 2 divided by concentration of A in the container at equilibrium raised by its stoichiometric coefficient 1 multiplied by concentration of B at equilibrium raised by its stoichiometric coefficient 1, right? That's what we'll be doing. Yes? Now people, what is the concentration of C in the container at equilibrium? It is 0.2. So it's going to be 0.2 ka square divided by concentration of A in the container at equilibrium is 0.15 raised by stoichiometric coefficient 1 multiplied by concentration of B at equilibrium, that is 0.05, right? You just need to solve this term. That is going to be your Kc, which you were supposed to calculate, right? I'm sure this sort of a question you can easily solve from now onwards. Is it clear to everyone? Let me show you the actual answer which you'll get after solving the equation. The actual answer is going to be 16/3, right? That's going to be the value of Kc, which you were supposed to calculate as far as the question was concerned, right? Yes? Perfect, my dear people. Have a look. This is one more question, one more simple concept which is involved in this particular question, right? From this particular question, you are going to learn one more concept. Have a look exactly how am I going to deal with this question. A very simple and basic question. Have a look, my dear people. The reaction that's given to me is something like this. It is N2 gas plus 3 times H2 gas. And it is in equilibrium with 2 times NH3 gas. This is the reaction that's given to us, right? This is the reaction that's given to us. Now, my dear people, this reaction, it has to take place in a closed container because all the reactants and products, they are in gaseous phase, right? Perfect. This reaction this reaction has to take place in a closed container, first of all, number one. Number two, initially at time t is equal to 0, there will be only moles of reactants present in the container. So initially at time t is equal to 0, whatever is going to be the pressure of the container, that is going to be due to N2 and H2, right? There'll be no contribution of NH3 towards the total pressure of the system at time t is equal to 0, number one. Now, when the reaction starts, what is going to happen? The number of moles of reactants will start to decrease and number of moles of products will start to increase. And there will be a time when equilibrium will be established in the reaction. So when equilibrium will be established in the reaction, you'll find few moles of N2 left in the container, few moles of H2 left in the container, and few moles of NH3 would have got formed in the container at equilibrium. So basically at equilibrium, you're going to find the moles of each reactant and product, right? And all the reactants and products, they are in gaseous phase. So I must say, whatever is going to be the total pressure of the mixture at equilibrium, total pressure of the system at equilibrium, all the three components will have its contribution towards the total pressure, right? So I must say, first of all, the total pressure at equilibrium should be equal. The pressure due to N2, which is what I call as partial pressure of N2, plus partial pressure of H2, plus partial pressure of NH3. I'm sure this is something you got to know, right? The total pressure of the mixture at equilibrium, the total pressure of the system at equilibrium will be equal to the sum of contribution made by each gas in the container at equilibrium, right? Now what is given to us? The partial pressure of N2 and H2 at equilibrium are given to us. Partial pressure of N2 is given to us as 0.8 atm. Partial pressure of H2 is given to us as 0.4 atm, right? Partial pressure of NH3 at equilibrium, we do not know that. But we know the total pressure of the system at equilibrium, that is 2.8 atm. 2.8 atm. So from this particular equation, you can calculate the partial pressure of NH3 at equilibrium, which will come out to be 1.6 atm. So this is the partial pressure of NH3 at equilibrium. So people, do I have the partial pressure of each reactant and product at equilibrium? Absolutely we have it. Absolutely we have it. So you can clearly write the expression for Kp. You can say Kp is nothing. It is partial pressure of NH3 at equilibrium raised by its stoichiometric coefficient, that's 2, divided by partial pressure of N2 at equilibrium raised by stoichiometric coefficient 1, partial pressure of H2 at equilibrium raised by stoichiometric coefficient, that is 3, right? If I ask you, what is the partial pressure of NH3 in the container at equilibrium? You must say it's 1.6 raised by its stoichiometric coefficient, that's 2, divided by partial pressure of N2 at equilibrium is given to me as 0.8 atm, multiplied by partial pressure of H2 at equilibrium is given to me as 0.4 and it's raised by 3. Now it's going to be your job to do a bit of calculation and get the value of Kp, which you were supposed to calculate as far as the question was concerned, right? I'm sure this sort of a question you can easily solve from now onwards if it is asked, right? Perfect. No, Durga, I did not start the thermodynamics yet. Just wait for it. This is the first chapter which we started. Yes, I'm sure it's clear to everyone. So the final answer of the question comes out to be 50. Now, this is one more question. Let's get to know how do we deal with this particular question. This question is going to make you understand one more concept. Have a look exactly how to tackle with this. Have a look exactly, guys. As far as the question is concerned, we are given with a reaction N2. N2 is reacting with H2 and it is leading to the formation of NH3. Since I wrote the reaction in the balanced form, right? Yes. And this reaction will be taking place in a container whose volume is exactly 1 liter. Find the concentration of NH3 at equilibrium. Find the concentration of NH3 at equilibrium. If equilibrium pressure is 1 atm and the equilibrium constant Kc is 4 by 27. So we are given with Kc value, right? We are given with Kc value. Have a look exactly how we are going to solve this question. Have a look, people. At time t is equal to 0, initially, we are given with 1 mole of N2. We are given with 3 moles of H2. Since the reaction would not have started yet, because I'm talking at time t is equal to 0, these are the initial conditions. So moles of NH3 at time t is equal to 0 is going to be 0 because the reaction has not started yet. These are the initial conditions, right? Now, people, at equilibrium, when equilibrium will be established in the reaction, I'll assume out of 1 mole of N2, there will be some x moles of N2 which would have reacted with H2. So I'll be left with some 1 minus x moles of N2 in the container at equilibrium. Now, as far as the stoichiometry is concerned, 1 mole of N2 reacts with 3 moles of H2. So I must say x moles of N2 should react with 3x moles of H2. So I had taken some 3 moles. Out of 3 moles, there are some 3x moles which are reacting. So I'll be left with 3 minus 3x moles of H2 in the container at equilibrium, right? Now, 1 mole of N2 gives 2 moles of NH3. So x moles are supposed to give me 2x moles of NH3, right? So these are basically the moles of each reactant and product which I got, right, at equilibrium. Perfect. Now, people, the volume of the vessel is given to us as 1 liter. So just divide this term with 1, this term with 1, this term with 1. So I'll be getting the concentration of each reactant and product at equilibrium. I got the concentration. Perfect. After getting the concentration, my dear people, I'll try to write the expression for Kc. What is going to be the Kc expression? Kc expression is going to be simple. It's going to be concentration of NH3 at equilibrium raised power 2. So it's going to be 2x raised power 2 because this is the concentration of NH3 at equilibrium. So it's square divided by concentration of N2 at equilibrium, that's 1 minus x raised power its stoichiometric coefficient 1. Similarly, concentration of H2 at equilibrium, that is 3 minus 3x raised power its stoichiometric coefficient, that's 3. This is how you're going to write. This is how you are going to write the expressions for Kc, right? Now, my dear people, have a look how am I going to further solve this one. Well, Kc value is given to me as 4 by 27. Kc value as for the question is given to me as 4 by 27. Now, this is going to be exactly 4x square. Numerator is going to be 4x square divided by. What I'll be exactly doing over here, if I take 3 out from the bracket, if I take 3 out, it will come out as 3 cube. That means 3 cube is 27. So this is 27. Now this is 1 minus x, and over here is going to be 1 minus x ka cube. 1 minus x into 1 minus x ka cube makes it 1 minus x raised power 4, right? So this 27 is over. This 4 got cancelled. So I got to know 1 is equal. This is x square. This is 1 minus x raised power 4. So you can write it as x divided by 1 minus x square whole raised power 2, right? You can write it like this, I'm sure, right? Now, if you take the square root on both the sides, it is simply going to be 1 is equal. This is going to be x divided by a square plus b square minus 2ab. Perfect. So from here, you got one quadratic equation. So this is going to be x is equal to 1 plus x square minus 2x. So you got the quadratic equation like this. This is x square minus 3x plus 1 is equal to 0. Well, this is the equation which you got. After getting this quadratic, I'm sure you guys know how to solve the quadratic, right? X is equal to minus b plus minus root b square minus 4ac divided by 2a. From there, you'll be getting the value of x. Once you get the value of x, what you were supposed to calculate? You were supposed to calculate the concentration of NH3 at equilibrium. And you know, concentration of NH3 at equilibrium is 2 times x. X value you'll get from here, put the value of x over here, and get the concentration of NH3 at equilibrium, which you were supposed to calculate, right? I'll be showing you the final answer of this particular question, right? Its final answer, wait. This is not the solution for this particular question. This is the other question. This is by mistake. They have pasted over here, right? So I hope you got to know how to deal with that question, which I've shown you, right? There was only calculation left. Just a second, guys. I don't know what's happening here. This is one other question. Just a second. Where is its exact question? Just a second. Just a second, guys. So I will have to write one question on my own. Just a second, guys. The reaction is AB3 gives AB2 plus half of B2. AB3 gives AB2 plus half of B2, right? This is the reaction that's given to us. I'm writing the question. This is the reaction that's given to us. Now, in this particular reaction, my dear people, what all things are given to us? Let me tell you that first of all. You're given with the initial pressure of the system. You're given with the initial pressure of the system, which was given to me as 900 torr. You're given with one more parameter. You're given with the total pressure of the system at equilibrium. That's given to us as 1000 torr. And what exactly we are supposed to calculate? We are supposed to calculate the value of Kp. This was the question exactly. This was the question exactly. See, guys, this is the reaction that's given to us, right? For this particular reaction, every reactant and product is first of all in gaseous state, number one. Number two, initial pressure of reactant is given to us as 900 torr. Total pressure of the system at equilibrium is given to us as 1000 torr, and we are supposed to get the Kp value. And how do I approach to this particular question? Have a look exactly. See, guys, at time t is equal to 0, the initial pressure of reactant, that's given to me as 900 torr, right? And at time t is equal to 0, initially there will be no product formed. There will be definitely no product formed, my dear people, at time t is equal to 0, right? So the pressure due to AB2 at time t is equal to 0 is going to be 0. Even this is going to be 0. Now, my dear people, what you are going to do, you are going to treat this pressure in the similar way as we used to treat the moles. You are going to treat the pressure in the similar way as we used to treat the moles. So I must say, at equilibrium, let's keep this as 900 minus x, right? Now, we used to do one thing. 1 mole gives 1 mole. From x, you get x, right? 1 mole gives 1 by 2. From x, you get x by 2. So you have treated this pressure as per moles, right? Yes? Now, what are these terms exactly? These are basically the partial pressures of each reactants and products at equilibrium. These are the partial pressures of each reactants and products at equilibrium, right? Since you got the partial pressures of each reactant and product at equilibrium, can I say total pressure of the system at equilibrium is given to me as 1000 torr? So can I say total pressure at equilibrium will be the sum of the partial pressure of AB, partial pressure of AB2, and partial pressure of B2, as simple as that. So I must say the total pressure of the system at equilibrium, that's going to be 900 minus x plus x by 2. This value is basically equal to 1000, right? Now this x got cancelled, so you got to know x by 2 is equal to 100. If x by 2 is equal to 100, from here you got as x is equal to 100 atm, since you got the value of x. Now what you are going to do with this particular x? Put the value of x into these terms over here. It's going to be 900 minus 200 comes out to be 700. So this is basically, sorry, the pressure is given in torr, it's not in atm. Now guys, this is basically the partial pressure of AB3 at equilibrium, right? This is x and x is 200 torr. So this is basically the partial pressure of AB2 at equilibrium, x by 2. So 200 by 2 comes out to be 100. So this 100 torr. This is the partial pressure of B2 present in the container at equilibrium. So you got the partial pressure of each reactant and product at equilibrium, my dear people, right? Well, after getting the partial pressures, what you'll be doing exactly, you'll be just writing the expression for Kp. Kp expression is nothing. It is partial pressure of AB2 at equilibrium. Partial pressure of AB2 at equilibrium raised by its stoichiometric coefficient, that's 1, right? Multiplied by partial pressure of B2 at equilibrium. Partial pressure of B2 at equilibrium raised by its stoichiometric coefficient, that's 1 by 2, whole divided by partial pressure of AB3. Partial pressure of AB3 at equilibrium raised by its stoichiometric coefficient, that's 1. Now you got all these partial pressures, right? So partial pressure of AB2 came out to be 200. Partial pressure of B2 came out to be 100. It's going to be 100 raised by 1 by 2, right? Divided by partial pressure of AB3 came out to be 700. So 100 raised by 1 by 2 is 10. So it becomes 2000 by 700. So final value comes like this, 2000 by 700. That means 20 divided by 7, right? And its units are going to be atm raised to the power delta Ng. What is delta Ng for this reaction? Number of moles of gaseous products, which is 1 plus 1 by 2, 3 by 2, minus number of moles of gaseous reactant, which is 1. So 3 by 2 minus 1 comes out to be 1 by 2, right? So this is going to be the final answer of the question, which we were supposed to calculate. Is it clear to everyone, right? Perfect. Let's now move on to one more question. This is one more question which is given to us, a very simple and basic question, right? Let's see exactly how to deal with this particular question, my dear people. Have a look. See, the reaction that's given to me is N2O4 gas. It's in equilibrium with 2 times NO2 gas. This is first of all the reaction that's given to me. The vapor density of N2O4 and NO2 mixture, right? So first of all, when equilibrium will be established in the reaction, there will be some moles of N2O4 as well as the moles of NO2 present in the container, right? Well, as far as the question is concerned, the vapor density of N2O4 and NO2 mixture, right? The vapor density of the equilibrium mixture he is talking about. And let me tell you, the vapor density of equilibrium mixture is represented by small d. That must be given to me. That is given to me as 30, right? What do I need to calculate? I need to calculate first of all the value of alpha. If I get the value of alpha, then you can calculate the percentage dissociation, which is always equal to alpha multiplied by 100. So my basic thing right here is to calculate the value of alpha. Now, how am I going to calculate this alpha over here? See guys, small d, that is the vapor density of the equilibrium mixture, that's given to me as 30, right? If I ask you, what will be the capital D, theoretical vapor density? Capital D stands for theoretical vapor density, right? And small d is the vapor density of the equilibrium mixture. And how do we calculate the theoretical vapor density? It's equal to molar mass of reactant divided by 2. What is the molar mass of reactant? It is supposed to be 92 grams per mole divided by 2. The value comes out to be 46, right? So you got the capital D, you got the small d. Now I'm going to give you one expression. I'm sure every one of you would have studied this expression. Alpha is equal to capital D minus small d divided by small d multiplied by n minus 1. What is this n over here? N stands for number of moles of products which are furnished from 1 mole of reactant. Have a look. From 1 mole of reactant, how many moles of products are produced? 2. So I must say n value over here is going to be 2. I must say n value over here is going to be 2. Now guys, get the value of alpha from here. See, capital D is nothing, it's 46. Small d is nothing, that's 30. Divided by small d is 30. N value is 2 minus 1. So this is going to be, the numerator comes out to be 16, right? Denominator comes out to be 30 exactly. The value will come out to be approximately 0.53, right? So this is the value of alpha which you got. But were we supposed to calculate the value of alpha? No, we were supposed to calculate the percentage dissociation. And let me tell you, percentage dissociation is nothing. It is just alpha multiplied by 100. So 0.53 multiplied by 100 comes out to be 53%. So what is meant by 53%? It means 53% of N2O4 would have got converted into NO2, then only equilibrium would have established in this particular reaction, right? That's something which I was supposed to calculate. I'm sure this again clear to every one of you. Perfect. Do you remember the approach of these questions, my dear people? This is one more similar sort of question, and I'm sure you can easily solve this one now, right? Have a look, people. The question says, if the percentage dissociation is 40, percentage dissociation is 40, that means alpha is equal to 0.4, right? Percentage dissociation is 40, that means first of all alpha is equal to 0.4. Yes? Calculate the vapor density of the equilibrium mixture. You need to calculate the small d value. Vapor density of the equilibrium mixture is represented by small d, and you need to calculate the small d value. Let's get to know how to calculate small d. Again, a similar sort of question. If I ask you what is the n value, check from 1 mole of reactant, how many moles of products we are getting? 1 plus 1, 2. So n value is 2. From 1 mole of reactant, you are getting 2 moles of products. So n value is 2 first of all. Now, you'll be using the formula alpha is equal to capital D minus small d divided by small d multiplied by n minus 1. My dear people, alpha value you already have, right? Alpha value you have. What is going to be capital D? What is going to be capital D? Theoretical vapor density. As I told you in the beginning, it's molar mass of reactant divided by 2. Now, what is the molar mass of reactant over here in this case? Molar mass of PCl5. Let's get to know. Phosphorus has got the molar mass of 31. Chlorine has got the molar mass of 35.5, and there are some 5 chlorine atoms, right? 5, 5, 25, 5, 5, 25, 27, 5, 3, 15, and this 177.5. So this is basically 177.5 plus 31. How much it comes out to be? It's going to be 7 plus 1, 8, 7, 3, 10, 208.5. So molar mass of reactant is equal to 208.5 divided by 2. The value comes out to be 104.25. This is the capital D value. This is the capital D value, right? Yes. So since you got the capital D value, you have the N value, you have the alpha value. So alpha value we got to know is 0.4 is equal. Capital D you got to know is it's 104.25 minus small d you need to calculate divided by small d, n minus 1. 2 minus 1 comes out to be 1 only. So my dear people, I can say you got one equation. And I can say you got one equation which just contains one variable, right? I'm sure you can easily cross multiply it and get the value of small d, which you were supposed to calculate, right? And small d is nothing, that is basically the vapor density of the equilibrium mixture, which we were supposed to calculate, right? Perfectly done. So after solving, finally you get the value of small d as 0.013. Yes? All right, look at this particular equation. We are given with a curve. And the curve is between capital D divided by small d versus alpha, right? Now, first of all, how to get this particular curve? Have a look exactly what I'm going to talk about now. Few minutes back only, I gave you the equation that's alpha is equal to capital D minus small d divided by small d multiplied by n minus 1, right? So this is going to be alpha multiplied by n minus 1. Take this n minus 1 over here. It's going to be capital D divided by small d minus 1, right? That's how I can write it. D minus D divided by small d. So it's capital D by small d minus 1 and take this n minus 1 over here. Perfect. So I can say capital D divided by small d is equal. This is going to be n minus 1 multiplied by alpha plus 1. You can just rearrange it like this. Well, people, capital D by small d you have arranged along y-axis and you have plotted this alpha along x-axis. So this capital D by small d is basically your y and this alpha is basically your x. So this should be automatically m and this should be automatically c. Y is equal to mx plus c is a straight line, right? It's given to me a straight line. Now what about the slope of this particular curve? Slope is represented by m and m value over here is basically n minus 1, right? So slope is equal to 2. So what is slope basically? Slope of the curve is equal to n minus 1. So n minus 1 is equal to 2. From here you got the value of n, that came out to be 3, right? Now people, what we are supposed to calculate? Have a look. Calculate the percentage dissociation when the experimental vapor density, that is small d, becomes equal to half of the theoretical vapor density. We need to calculate the value of alpha when small d becomes equal to capital D divided by 2. Again, a simple question. Now you shall be using the relation alpha is equal to capital D minus small d, right? Divided by small d multiplied by n minus 1, right? This is the expression which I'll be using. We need to get the value of alpha. Now see, it's going to be simply capital D minus small d is capital D divided by 2 divided by small d is again capital D divided by 2, n minus 1. N minus 1 is directly equal to 2, right? N minus 1 is directly equal to 2. So this 2, right? Or keep this 2 over here only. D minus D by 2 comes out to be D by 2. D by 2 got cancelled out. So it comes out to be 1 by 2. 1 by 2 is 0.5, right? So you got the value of alpha as 0.5. If you got the value of alpha as 0.5, I can say percentage dissociation, it's nothing. It's alpha multiplied by 100. 0.5 multiplied by 100 comes out to be 50, right? So 50% of the reactant would have got converted into the product, which is something we were supposed to calculate, right? Is it clear to everyone? Let me know quickly in the chats once. Let me know quickly in the chats, my dear people, if it is super clear to everyone so that I can move on. The question based on your Le-Chatelier's principle. What Le-Chatelier principle states? A simple statement of Le-Chatelier principle. Whenever you will find a system which will be present at equilibrium, whatever change you are going to impose on the system, equilibrium is exactly going to do opposite of what you do to the system. Equilibrium exactly does opposite of what we do to the system, which is at equilibrium. That's something which you need to remember. That's all, right? Now have a look. Predict the direction of shift of equilibrium. First thing, the reaction that's given to me is N2 plus 3 times H2 plus 100 kilojoules gives 2 times NH3. It is the hypothetical reaction basically, right? Because you know Haber's process, it's not endothermic basically, it's exothermic, perfect. But over here it's given as endothermic. Anyways, have a look. This reaction, I'm assuming it's at equilibrium, number one. Perfect. The reaction is at equilibrium. Now, what is going to be the direction of shift of equilibrium if more H2 is added? If you add more H2, we are adding more H2. Equilibrium will do opposite. It will decrease the amount of H2. And how it's going to decrease the amount of H2? When it will make sure the reaction moves forward. So, I must say, equilibrium shifts forward in the first case. If NH3 is added, if we add NH3 to the system, equilibrium is going to decrease the amount of NH3. And how it will be decreasing the amount of NH3? When it will make sure the reaction moves backward, the equilibrium shifts backward. So in the second case, equilibrium shifts backward. If temperature is increased, since it is the endothermic reaction, right? Since it is the endothermic reaction, what happens basically to the endothermic reaction? Have a look. There is one relation which you must know. Log of K2 divided by K1 is equal to delta H divided by 2.303 R. This is T2 minus T1 divided by T1 T2. This is one of the equations which you basically derive in your chemical kinetics chapter, right? What is K1? K1 is something which I'm calling as equilibrium constant of the reaction at temperature T1, right? Have a look. For example, you have got the reaction like this, A in equilibrium with B, right? Let's say when the temperature of the reaction was T1, its equilibrium constant was K1. For example, I'm changing the temperature of the reaction to T2. I'm assuming its equilibrium constant is K2, right? Have a look exactly what's going to happen. First of all, is the reaction endothermic or exothermic? As far as the reaction is concerned, it's given to me as endothermic. If it is endothermic, delta H is going to be positive, right? Delta H is positive. Now people, since if we increase the temperature of the reaction, can I say T2 minus T1 value will come out to be positive? If T2 minus T1 comes out to be positive, can I say this term is coming out to be positive? This term is positive, this term is positive. That means overall term is positive. What is meant by that? That means log of K2 divided by K1 is positive. When is that possible? When can be log of K2 by K1 positive? That is only possible when K2 divided by K1 will be greater than 1, which is only possible when K2 is greater than K1. So basically, on increasing the temperature, what is happening to the equilibrium constant? Equilibrium constant is increasing, right? On increasing the temperature, equilibrium constant is increasing for the endothermic reaction. Now, when temperature is increased, we are increasing the temperature. What will happen to the equilibrium constant? Equilibrium constant will increase. And how equilibrium constant will increase? When the equilibrium shifts forward, right? So this is going to be the forward direction, right? This is going to be the forward direction. Inert gas is added at constant volume. Whenever inert gas is added at constant volume to the system which is at equilibrium, there will be no shift of equilibrium, no shift at all. Inert gas at constant volume, no shift at all. Now similarly, my dear people, inert gas is added at constant pressure. You can easily solve this one as well, right? You can easily solve this one as well. So what is going to be the direction of shift of equilibrium when inert gas is added at constant pressure? Can you let me know? Can you let me know, my dear people? What is going to happen first? When inert gas is added at constant volume, there will be no effect, right? But there will be effect when the inert gas will be added at constant pressure. And this is going to be your homework. Do let me know its answer in the comment section of the video afterwards, right? It again is very simple based on again the Le-Chatelier principle. Do let me know its answer in the comment section, right? I'm keeping it to you as such. Perfect. Moving on to one more. All right, what do you think about this one? The equilibrium. You're given with the reaction is attained at 25 degrees centigrade in a closed container and an inert gas is added. Which statement is correct? So basically, we are adding again the inert gas in the closed container. Closed container means volume of the system is constant, right? So basically, you are adding inert gas at constant volume. And we know addition of inert gas at constant volume does not affect the equilibrium constant at all. So no effect, right? No change in the concentration of each. No change in the concentration of each. So it's option B, which is supposed to be the correct answer of this particular question as well, right? Perfect. I'm sure this again clear to everyone. Right, people? Perfect. So this was about the chemical equilibrium. Now let's start the ionic equilibrium, right? Is every single thing clear, my dear people? Just let me know quickly in the chats. Is every single thing clear? Is every single thing clear till here? Perfectly done. Just give me a second. All right, guys. So let's get started with the concepts of ionic equilibrium, and let's see what kind of questions can be asked out of this particular chapter, right? One by one, we are going to make them clear, right? The first and the very simple question, which is on your screen. Let's give it a try and let's see how do we solve this sort of equation. Have a look, guys. The question says, calculate the H positive ion concentration of 0.05 molar CH3COH solution. So basically, you're starting with CH3COH aqueous solution. If I ask you if it is a weak acid or strong acid, CH3COH, you guys must be knowing it's a weak acid, and weak acids as well as weak bases, they are assumed, they are considered as the weak electrolytes, and all the weak electrolytes, they always remain in equilibrium with their ions, and its ions are going to be CH3CO negative aqueous plus H positive aqueous, right? This is going to be the reaction first of all, right? Now, first of all, my dear people, I'm going to show you the approach of solving this particular question. There is one basic procedure which you need to remember, that's all. Have a look exactly. I'll say at time t is equal to 0, let's assume the concentration of CH3COH is C. Well, the concentration of CH3COH, that's given to me. That means this 0.05 molar, it is basically the value of C. It is basically the value of C, yeah? Right? This is C. I'm assuming the degree of ionization of this weak electrolyte is alpha, right? Since at time t is equal to 0, the reaction wouldn't have started. So this is 0, right? Now, my dear people, you are going to treat the concentration in the similar way as we used to treat the moles, right? So I must say, at equilibrium, what is the concentration of CH3COH left? It's going to be C minus C alpha. 1 mole gives 1 mole. From C alpha, you get C alpha. Even this is from 1 mole, you get 1 mole of H positive. From C alpha, you get the C alpha. So basically, you got the concentration of each reactant and product in the container at equilibrium, as simple as that, right? Now, I would want you guys to write the expression for dissociation constant of this weak acid, Ka. How do I write the expression for dissociation constant of weak acid K? This K is basically equilibrium constant only. This K is basically equilibrium constant only. But for a weak acid, which is in equilibrium with its ions, we are using the term Ka for it, right? Which is what we call as dissociation constant of the weak acid, right? How do I write its expression? It's written in the similar way as we used to write the expression for Kc, right? It's going to be concentration of CH3CO negative at equilibrium, that is C alpha raised by stoichiometric coefficient. So C alpha raised by 1. Concentration of H positive at equilibrium raised by stoichiometric coefficient, that's C alpha raised by 1. Divided by concentration of CH3COH, that is C minus C alpha. So I'll take C as common, 1 minus alpha, right? So can I say one of the C gets cancelled out. It comes out to be C alpha square divided by 1 minus alpha. So first of all, what you did exactly, you calculate the value of Ka, and Ka value came out to be C alpha square divided by 1 minus alpha. After this, what we are supposed to do? Do remember the procedure, my dear people, right? After this, you'll make certain assumptions. You'll say, let alpha value is less than 0.05. You are doing the assumption, let the value of alpha be less than 0.05. And since we are assuming alpha value is less than 0.05, whenever the value of alpha comes out to be less than 0.05, at that point of time, instead of 1 minus alpha, you can just write 1. That means you can neglect alpha in comparison to 1. So again, if I want you to write the expression for Ka, Ka now becomes C alpha square only. K becomes C alpha square. If Ka becomes C alpha square, so what you can do over here, you can get the value of alpha, which is coming out to be under root of Ka divided by C. So alpha value is coming out to be under root of Ka by C. So whenever alpha is neglected in this particular question, you'll be getting the value of alpha as under root of Ka by C. Well, people, if I ask you, do you know the value of Ka? Absolutely, we know it, 1.25 into 10 raised by minus 6. Do you know the value of C? What is C? C is basically the concentration of weak acid, that's 0.05. This is 0.05, right? So alpha from here, you need to solve it. This is 1. This is 25 times. Root of 25 is 5. Root of 10 raised by minus 6 is 10 raised by minus 3. So the value is coming out to be 0.005, right? Since I had assumed the value of alpha to be less than 0.05. Is the alpha value actually coming out to be less than 0.05? Absolutely. That means whatever assumption you have done over here, that's absolutely correct, right? Whatever assumption you have made over here, that's absolutely correct. So alpha value you got to know as 0.0005, something like that, right? Now what you were supposed to calculate? You were supposed to calculate the concentration of H positive in the container at equilibrium. And you know, concentration of H positive in the container at equilibrium is nothing, that's C alpha. So you can say concentration of H positive at equilibrium is equal to C multiplied by alpha. What is C? C is 0.05, that means 5 into 10 raised per minus 2. And alpha is nothing, that is 5 into 10 raised per minus 3. So the final value comes out to be 25 into 10 raised power minus 5 molar. So this is basically the concentration of H positive present in the container at equilibrium, which we were supposed to calculate. I'm sure you got to know the procedure of solving this sort of equation, right? Right, my dear people? Yes, Sairam, you can watch it for JE as well, no issues. Yes? Perfect, guys. Perfectly done. Let's move on and try to solve one more question, one more concept. See, guys, this is one more question which is given to us, and this question will make us understand one more concept, right? And I would want you guys to remember these approaches, right? Like how to tackle different types of questions. See, it's again a very simple question. The question is something like this. Calculate the ionization constant of a weak base. So basically, I'm given with a weak base, which is NH4OH aqueous, right? Since weak bases are again weak electrolytes, and you know, weak electrolytes always remain in equilibrium with its ions. So NH4OH would have got dissociated as NH4 positive aqueous. With this, you'll be writing OH negative aqueous, right? This is first of all the reaction which you are going to write over here. If stoichiometry is there, Gokul is saying, sir, what if stoichiometry comes? If stoichiometry is there, then you have to involve stoichiometry as well. For example, over here it was supposed to be 2. Then it's not going to be C alpha, it's going to be 2 times C alpha, right? But in your examination, the stoichiometry will always be 1:1:1 only. Do remember that. In your NEET examination, they don't play with the stoichiometries. Relax, right? Okay. Now, guys, what is given to me? If the concentration of OH negative is given to me as 0.05 molar in the container at equilibrium, right? And concentration of NH4OH in the beginning is given to me as 0.1 molar. What do I need to calculate? We need to calculate the ionization constant of the weak base, which I represent with Kb. Perfect. So how do we solve this particular question? See, guys, again, I'm going to use the same approach which I used in the last question. I'll say at time t is equal to 0. For example, its concentration is C, this is 0, and this is 0. Let's assume the degree of ionization is alpha. So at equilibrium, this is going to be C minus C alpha. 1 mole gives 1 mole from C alpha, you get C alpha. 1 mole gives 1 mole from C alpha, you are again getting C alpha, right? Now again, you'll be writing the expression for Kb, my dear people. How do I write the expression for Kb? In the similar way, concentration of NH4 positive at equilibrium, that is C alpha. Concentration of OH negative at equilibrium, that's again C alpha. Divided by concentration of NH4 at equilibrium, that is C minus C alpha. So finally, again, it's going to come as C alpha squared divided by 1 minus alpha, right? But one thing that's given to me as per the question, what is that? Have a look. I'm given with the fact concentration of OH negative at equilibrium is 0.05. But people, if I ask you, what is the concentration of OH negative at equilibrium? That is C alpha. That means C alpha value is given to me as 0.05. So from this particular equation, you can get the value of alpha as 0.05 divided by C. And what is C? C is the concentration of this weak electrolyte. That's 0.1, right? So alpha value is coming out to be 0.5. Now have a look. Alpha value is coming out to be 0.5. If alpha is 0.5, so can I neglect alpha in comparison to 1? See, guys. When do we neglect alpha? We neglect alpha when the value of alpha comes out to be less than 0.05. But over here, it's not less than 0.05. It is more than 0.05, right? So I'm not going to neglect alpha in comparison to 1. So in order to get the value of dissociation constant of the weak base, I cannot neglect alpha in comparison to 1. So it's going to be C. C value is 0.1. 0.1 means 10 raised power minus 1, raised power 2. It's going to be alpha square. Alpha is 0.5, right? Alpha is 0.5, so make it 0.5 square. Divided by 1 minus 0.5 comes out to be 0.5 only. So 1.5 cancelled out. So this is 10 raised power minus 2. And this one will be 25 into 10 raised power minus 2. So the final value comes out to be 25 into 10 raised power minus 4. This is the value of Kb, which you were supposed to calculate as far as the question is concerned, right? I'm sure easily you can solve this sort of question again. Perfect. Perfectly done, guys. Yes? Did we do some mistake? I think we did some, is it 0.5? No, they have given the incorrect answer. 1 minus 0.5 is 0.5, 0.5 cancelled. So 0.5 into 0, it comes out to be 0.05, something like that. I think we did some calculation mistake at the end. You can check it afterwards, right? Do check it afterwards. Okay. Calculate the concentration of each species at equilibrium in an aqueous solution containing. These are the two questions which are given to us. Right? See guys, the first question is very easy. If in the container there is only 0.1 molar NH4OH, you need to calculate the concentration of each species. You can do it by using the same concept which I was doing till now, right? Yes. The second question is slightly different. Second question is slightly different and simple at the same time. Let's try to solve the first one. Then we can go for the second one. Have a look. The first question says, calculate the concentration of each species at equilibrium in an aqueous solution containing 0.1 molar NH4OH. So basically in the container, you have got NH4OH, which is basically a weak base, which is going to remain in equilibrium with its ions, which is NH4 positive aqueous plus OH negative aqueous, right? Perfect. Weak base in equilibrium with its ions. Perfect. The first question I'm solving. Again, the similar procedure. This is C, this is 0, this is 0. This is supposed to be C minus C alpha at equilibrium. This is supposed to be C alpha. This is supposed to be C alpha. Again, KB expression, you'll be using C alpha square divided by 1 minus alpha. Same things I'm doing. Now, assumption. Let alpha value be less than 0.05. At that point of time, 1 minus alpha can be written as 1. At that point of time, alpha is going to be under root of KB by C. Right? Under root of KB value is 1.8 into 10 raised power minus 5 divided by C. C value is 0.1, that means 10 raised power minus 1. Root of 1.8 comes out to be 1.34 into 10 raised power, it will come out to be minus 2. Have a look. Is the value of alpha actually coming out to be less than 0.05? Check it out. Check it out, people. I assumed let the value of alpha be less than 0.05. Is the value of alpha actually coming out to be less than 0.05 only? Absolutely. That means whatever assumption we have done, that's absolutely correct. So alpha value you got. Right? So whenever you'll be having only NH4OH in the container, in equilibrium with its ions, its alpha value is actually less than 0.05. Perfect. Now what we are supposed to calculate? The concentration of each ion at equilibrium. What is the concentration of NH4 positive at equilibrium? C alpha. Since alpha you got, C value is given to us as per the question. C is the concentration of this NH4OH. So C multiplied by alpha will give you the concentration of NH4 positive as well as OH negative. So this sort of a question is damn easy, right? Now, the second part of the question. Look at the second part of the question, my dear people. If 0.1 molar NH4Cl along with NH4OH, what is the concentration of NH4OH? It is 0.1 molar. Perfect. Now what you are going to do? Now you are going to introduce NH4OH into a solution containing 0.1 molar NH4Cl. Perfect. Have a look how this sort of a question is to be solved. So first of all, in the container, you have got NH4OH, which is a weak base. So it is absolutely going to remain in equilibrium with its ions, and its ions are absolutely going to be NH4 positive aqueous plus OH negative aqueous, right? Perfect. This is something you guys know. Yeah. Now people, let's assume its concentration is C. This is 0. This is 0. Let's assume its degree of ionization is alpha. Now at equilibrium, it's supposed to be C minus C alpha. This is going to be C alpha. This is going to be C alpha. Perfect. This is something which you know already, right? Now guys, what is the value of C? C value is given to me as per the equation, that's 0.1 molar, right? Now, the container which contains NH4OH, in the same container, you are introducing NH4Cl. You are introducing NH4Cl. Let me tell you this NH4Cl, it is a strong electrolyte. If it is a strong electrolyte, it will get completely dissociated into its ions. Its ions are NH4 positive plus Cl negative, right? It will get completely dissociated. Well, let's assume its concentration is C1, and C1 is given to me, its concentration is given to me as 0.1, right? So initially this will be 0, this will be 0. Now this is a strong electrolyte, it would have got completely dissociated into its ions, so I'd be left with nothing. 1 mole gives 1 mole, so from C1 you get C1, this also C1. Now people, can you see, in the same container, what do we have? In the same container we have got two electrolytes. One is a weak electrolyte, one is a strong electrolyte. And both the electrolytes, they have got one ion in common. Both the electrolytes, they have got one ion in common. So which effect you are going to operate over here? You are going to operate the common ion effect. And as far as the common ion effect is concerned, whenever in a container, you'll be having a weak electrolyte and a strong electrolyte, both having one ion in common, right? As per common ion effect, what happens? This reaction, it shifts backward. If it shifts backward, that means the degree of ionization, that means alpha value decreases. Already, when NH4OH was alone in the container, without this NH4Cl, its alpha value was already less than 0.05. Now, due to common ion effect, the reaction shifted backwards. Its alpha value would have got further suppressed, right? Its alpha value would have got further decreased. And that decrease in the value of alpha for the weak electrolyte, when a strong electrolyte containing common ion is added to it, this effect is called as common ion effect. So what I can do over here, I can neglect alpha wherever I want it, right? I can neglect alpha wherever I want to neglect it, right? If I ask you what is the concentration of the common ion, this NH4 positive, its concentration is right here C alpha, concentration of NH4 positive over here is C1, so it's going to be total C1 plus C alpha, right? Since alpha value has decreased, alpha value is already less than 0.05, now due to common ion effect, it's further decreased, right? So instead of C1 plus C alpha, I'll be only writing C1, right? Now, you'll be writing the expression for Kb. What is going to be the Kb expression? Kb expression for this weak base is concentration of NH4 positive, which is C1 multiplied by concentration of OH negative, which is C alpha, divided by concentration of NH4OH, that is C minus C alpha. So C take as common, 1 minus alpha. So one of the C gets cancelled. Instead of 1 minus alpha, you can write 1, right? So you got Kb is equal to C1 multiplied by alpha. So you can get the value of alpha from here. It's going to be Kb divided by C1. What is the value of Kb? Kb value is given to me as per the question, 1.8 in 10 raised power minus 5. What is the value of C1? It is 0.1. 0.1 means 10 raised power minus 1. So the value comes out to be 1.8 into 10 raised power minus 4. This is the value of alpha, my dear people. This is the value of alpha, right? If you want to check whether the alpha value has reduced or not, already in the container when NH4OH was present alone, its alpha was 1.34 in 10 raised power minus 2. Now after the addition of strong electrolyte, alpha value, check it, 1.8 in 10 raised power minus 4. So alpha has actually decreased. Alpha has actually suppressed, decreased, right? Since you got the new alpha over here, so what we're supposed to calculate? The concentration of each ion. So I must say the concentration of NH4 positive in the container now finally is going to be concentration of NH4 positive is equal to C1, and C1 value you know that's equal to 0.1 molar, and concentration of OH negative in the container finally at equilibrium it's going to be C alpha. C value you already know that's 0.1, and alpha value you have calculated that is 1.8 into 10 raised power minus 4. So this is going to be 1.8 into 10 raised power minus 5 molar. This is basically the concentration of OH negative in the container at equilibrium at the end, right? I'm sure this sort of a question you can solve from now on. Perfect. The question based on common ion effect. And this common ion effect, this sort of approach is also used in the questions based on solubility as well, right? I'm sure you can easily solve this sort of question from now on. All right, now there are certain questions which are based on pH. Have a look. See guys, calculate the pH of the following. The first is 10 raised power minus 7 molar HCl. So first of all, you have got HCl aqueous basically. What is meant by this? That means you are putting HCl into water. You are putting HCl into water. When you will put HCl into water, what's going to happen? It's going to give away H positive ions and Cl negative ions. As simple as that, right? H positive ions and Cl negative ions. So basically, you have got a container in which already there is water, right? Now in the same container, you are putting HCl. The HCl would have got dissociated as H positive and Cl negative. Perfect. Now at time t is equal to 0, what about the concentration of HCl? That is 10 raised power minus 7 molar, right? This is going to be 0, this is going to be 0. Since HCl is a strong acid, strong electrolyte, it would have got completely dissociated into its ions, so I'll be left with nothing. 1 mole gives 1 mole, from 10 raised power minus 7, you get 10 raised power minus 7 molar. Even this is 10 raised power minus 7 molar. So from this acid, if I ask you, so first of all, this is the acid basically, which you are putting in the container. Container already was containing water. There was already water in the container. In that container, you are putting HCl, right? Now, what is going to be the concentration of H positive ions, which is coming into the container due to this acid? It is 10 raised power minus 7 molar. It is 10 raised power minus 7 molar. Perfect. Already in the container, there was water. Already in the container, there was water. And I'm sure you guys know water is considered as a weak electrolyte, right? Water is considered as a weak electrolyte. So already in the container, due to the ionization of the water, the already H positive ion concentration before this 10 raised power minus 7 was already 10 raised power minus 7 molar at 25 degrees centigrade, right? Yes. So it's going to be 2 times 10 raised power minus 7. This is the net H positive ion concentration in the container. Perfect. This one is the H positive ion concentration which is coming in the container due to HCl. And this one is the H positive ion concentration which was already there in the container due to water, right? Due to water. Perfect. Now people, if you got the H positive ion concentration, total H positive ion concentration, you can calculate the pH of the solution. P stands for minus log. H positive concentration is 10 raised power minus 7. Now you need to use the property of log. It's going to be minus log of 2 plus what? Plus log of 10 raised power minus 7, right? Perfect. So it's going to be minus times. Log of 2 is nothing, that's 0.3. 10 raised power minus 7 is minus 7. So the final pH of the solution comes out to be 6.7, right? So this is the final answer of the question. 6.7 is the resulting pH of the solution. That's all, right? Yes? Clear to everyone? Absolutely, guys. Wonderful. Let's have a look on one more question. See, a lot of you might be thinking, why did I introduce the H positive ions which are coming from water? For example, you are neglecting this H positive ion concentration which are coming from water. You are only saying there are total 10 raised power minus 7 molar H positive in the container, for example, right? So you will be calculating the pH, which will be minus log of 10 raised power minus 7. So the pH comes out to be 7 then, right? But if the pH comes out to be 7, solution is supposed to be neutral, but you are putting acid. Acidic solution always has pH less than 7. So this cannot be the answer, right? So its actual pH is 6.7. Do remember it. Look at the next question, my dear people. It's 10 raised power minus 8 molar NaOH. Now in the container, basically, you have got NaOH, right? NaOH, it's again a strong base. You're putting this NaOH into the water. It will be getting completely dissociated into Na positive aqueous plus OH negative aqueous, right? Yes. Now its concentration is given to me as 10 raised power minus 8 molar. This is 0, this is 0. Now this is going to be 0. This will be 10 raised power minus 8 molar. This will be 10 raised power minus 8 molar. So basically, you're putting NaOH into the container which already contains water, right? So if I ask you, since in the container there was already water present, water is again the weak electrolyte, it will be in equilibrium with its ions, right? So if I ask you, the concentration of OH negative already in the container due to water, that's already 10 raised power minus 7 molar. Now due to this base, what is the new OH negative ion concentration coming? The new OH negative ion concentration is 10 raised power minus 8 molar. So I must say the net OH negative ion concentration is going to be 10 raised power minus 7 plus 10 raised power minus 8 molar, right? This is the concentration of OH negative which was already there in the container due to the ionization of water. This is the concentration of OH negative which is coming into the container due to the addition of NaOH, right? Perfect, I'm sure till here it's clear. Now, if you take 10 raised power minus 8 as common, right? It's going to be 10 plus 1, that means the value comes out to be 10 raised power minus 8 into 11, right? This is the net OH negative ion concentration. If this is the net OH negative ion concentration, just do one thing, calculate pOH of the solution. pOH minus log of OH negative. OH negative is 10 raised power minus 8 multiplied by 11, right? So it stands for minus. This is going to be log of 10 raised power minus 8, right? Plus log of 11, right? That's how you're going to solve it. Now it's going to be minus times. Log of 10 raised power minus 8 comes out to be minus 8, right? Log of 11 will be 1.05. Yes. So the value over here will come out to be how much? The value will come out to be how much? It will come out to be 6.95, right? What is the 6.95? This is the pOH of the solution. But, if you were supposed to calculate pOH or pH, you were supposed to calculate pH of the solution. At 25 degrees centigrade, I'm sure you guys know, pH plus pOH is equal to 14. So from here, you can calculate pH, which is 14 minus pOH. So 14 minus 6.95 comes out to be 7.05. So this is basically the pH of the resulting solution, which you were supposed to calculate. If it is clear to everyone, then let me know in the chats fast. Let me know in the chats if it is super clear to everyone, my dear people. Yes? Let me know quickly in the chats. Anjali, I'll be doing them soon. Just wait for them. All right. Moving on to one more. Calculate the pH of the mixture. Calculate the pH of the following mixture. See, guys, how to solve this particular question. Have a look at exactly what the question is all about. See, basically in the same container, you are adding two strong acids. These are two strong acids which you are introducing into the same container, right? After the addition of two strong acids into the same container, the resulting mixture which we'll have, we need to calculate the pH of that resulting mixture. And how do we calculate that? Have a look. First of all, you're introducing H2SO4 into the container, and at the same time, in the same container, you are introducing HCl, right? Now, how this H2SO4 will get dissociated? It will get dissociated as 2 times H positive plus SO4 dinegative, right? In the similar way, how this HCl is going to get dissociated? H positive plus Cl negative. This is how both these acids are going to get dissociated, right? Now, my dear people, have a look. Both these strong acids you are putting into the same container. From this acid, H positives are coming into the container. From this acid also, H positives are coming into the container. So what you need to do exactly, you need to calculate the total H positives which will be there in the container after the addition of two acids, right? Once you get the total H positive and concentration, just take its minus log, get the pH, that's all. That's the approach of the question. And how am I going to solve it? Have a look. At time t is equal to 0, do I know the molarity of this H2SO4 solution? Yes, we know it. Do we know its volume in ml? Yes. We know the molarity of this particular solution. We know its volume as in ml as well. So I'll be multiplying these two terms, molarity of the solution multiplied by volume of the solution in milliliters. It gives me the number of millimoles of solute. So if I ask you, in this H2SO4 solution, how many millimoles of H2SO4 were there? 200 multiplied by 0.5 makes it 200. So these are the millimoles of H2SO4 which were present in this particular solution. So this will be 0 at time t is equal to 0. This is going to be 0. Now, it's a strong electrolyte. It would have got dissociated completely into its ions. So this is going to be 0. 1 mole gives 2 mole. From 200 you get 400 millimoles. This again going to be 200 millimoles. So basically you got to know the millimoles of H positive which are coming into the container due to H2SO4. That's 200, right? That's 200. Perfect. Now have a look. At time t is equal to 0, if I ask you how many millimoles of HCl do you have in this particular solution? Molarity of the solution multiplied by its volume in ml. So this multiplied by this, again it comes out to be 200 millimoles. This is 0, this is 0. Now this is 0, this is going to be 200, this is going to be 200. These are the millimoles of H positive which are coming into the container due to HCl, right? Now if I ask you how many total millimoles are there in the container? How many total millimoles of H positive are there in the container? You will say 400 plus 200 comes out to be 600. Once you get the total millimoles of H positives in the container, you'll be calculating the total H positive ion concentration, or you call it as the net H positive ion concentration. It's going to be equal millimoles of H positive in the container divided by total volume of the solutions, which is 400 plus 400 comes out to be 800. The value comes out to be exactly 3 by 4. So this is the net H positive ion concentration which is there in the container, right? Once you get the net H positive ion concentration in the container, you can easily calculate the pH of the solution now. It's going to be minus log of H positive ion concentration. So it's going to be minus times log of. H positive ion concentration is nothing, that's 3 by 4, right? So it's going to be minus log of m by n, which is going to be log of m minus log of n. Perfect. Log of 3 is 0.47, this 0.6, so the value comes out to be 0.13. So this is basically the resulting pH of the solution which we were supposed to calculate, right? I hope it's clear to everyone. Yes? So do remember the approach from now onwards. Now people, this is the similar sort of question. This is the similar sort of question which you need to solve, right? Which you will be solving. And you will let me know its answer in the comment section of the video afterwards, right? Similar sort of question. We are mixing two strong acids and you need to calculate the pH of the resulting mixture. I would want you guys to give it a try and let me know its answer. Will you give it a try or you want me to solve this question? Can you let me know in the chats? Do you want me to solve this particular question or you will do it on your own? Just say it in the chats. What do you want exactly? I mean, can you solve this question on your own or you want me to solve it? Let me know. All right, perfect then. Then do it, do give it a try, and do let me know its answer in the comment section, right? Afterwards. Perfect, guys. Have a look at one more question. The question is, calculate the pH of 0.1 molar HCl mixed with 0.1 molar CH3COH, right? 0.1 molar HCl mixed with 0. Someone is saying, sir, do it fast. Bro, you can watch the session tomorrow maybe, right? This is going to be the pace which I'm going to follow, right? Do it, watch it tomorrow and watch it at 1.25, 1.5. Perfect. Now have a look, people, how this sort of a question is to be solved. Calculate the pH of 0.1 molar HCl which is mixed with 0.1 molar CH3COH. First of all, just identify the two things which are given to me. This is first of all a strong acid HCl is a strong acid. The CH3COH is a weak acid. So basically you are adding strong acid and the weak acid into the same container, right? You're adding a strong acid and the weak acid into the same container. What is my weak acid? That is CH3COH. So CH3COH, if it is a weak acid, it is going to remain in equilibrium with its ions, and its ions are going to be CH3CO negative aqueous plus H positive aqueous, right? As simple as that. Right, people? Now have a look. At time t is equal to 0, I'm assuming its concentration is C. This is going to be 0, this is going to be 0. Now at equilibrium, it's going to be C minus C alpha. This is going to be C alpha, and this is going to be C alpha, right? Perfect. Now we will have a look. What is the value of C? C is the concentration of CH3COH. What is the concentration of CH3COH that's given to me? That's 0.1 mole. Perfect. Now, I must say, the container in which there is this CH3COH, in the same container you are putting HCl. You are putting HCl. HCl is a basically strong acid. If HCl is a strong acid, it would have got dissociated completely into its ions. Its ions are H positive plus Cl negative, right? What is the concentration of HCl which you are putting into the same container, which I'm representing with C1? It was 0.1, right? So initially this will be 0, this will be 0. Now this is a strong acid, so strong electrolyte. It would get dissociated completely into its ions. So this is 0, this will be 0.1. Sorry, let me not write 0. This will be C1 and this will be C1. Now we will have a look exactly. In the same container, what do we have? In the same container, we have got a weak electrolyte and a strong electrolyte. And both the electrolytes are having one ion in common. What is that? One common ion, H positive. If I ask you, what is the net H positive ion concentration then? It is C alpha plus C1. So which effect you are going to operate over here? You are going to operate again the common ion effect, right? And due to the common ion effect, what happens to the degree of dissociation of weak electrolyte? That suppresses, that further decreases. So I'm assuming alpha value has got already less than 0.05. So instead of C1 plus C alpha, you'll be already writing C1. So basically what you got? You got the concentration of H positive finally in the container, that is C1. And C1 value is nothing, that's 0.1. 0.1 means 10 raised per minus 1 molar. So you got the concentration of H positive in the resulting solution, which is 10 raised per minus 1 molar. If you got the concentration of H positive in the final solution, you can easily calculate pH, right? I must say pH is equal to minus log of H positive, right? Minus log of H positive. So the pH of the resulting solution comes out to be 1. Perfect, people? Right? So do remember, from this particular question, you can conclude one important thing. You can conclude one important thing, which is going to be helpful for you. See, what is the common ion over here? Common ion was H positive. Can I say the concentration of the common ion, is every time decided by the strong electrolyte. Do remember it? Concentration of the common ion is entirely governed, is entirely decided by the strong electrolyte. Perfect. From the strong electrolyte, H positive ion concentration was C1. So that is why total H positive ion concentration came out to be C1 only. Perfect. So take its minus log. The question is done and dusted. Perfect. So you were not supposed to solve this particular question in detail like this. If you knew the concept, the concentration of common ion is decided by the strong electrolyte. Strong electrolyte is HCl over here. From HCl, the concentration of H positive will be 0.1. So take its minus log. Get the value of pH of the resulting solution. That's all. That's how you solve this particular question in lesser time, right? I'm sure you can do it from now on. Perfect. So let me quickly move on to one more question. Calculate the hydrolysis constant, degree of hydrolysis for this. Whenever you get the question on the hydrolysis, right, on the salt hydrolysis, all the time in your NEET examination, my dear people, you get the questions which are directly going to be memory based from the salt hydrolysis. You just need to identify whether the salt, which type of salt it is. So I'm going to give you certain results. I would want you guys to remember those results from now on, because the questions are always, all the time going to be all formula based when it comes to salt hydrolysis, right? So first of all, if you will be having a salt of strong acid and weak base, if you will be having a salt of strong acid and weak base, whenever a salt of strong acid and weak base undergoes hydrolysis, whenever salt of strong acid and weak base undergoes hydrolysis, how do we calculate the hydrolysis constant, KH? Do remember, KH over here is equal to KW divided by KB. Perfect. Where KW at 25 degrees centigrade is 10 raised by minus 14, and KB will be given to us in the question, right? The another question, That is degree of hydrolysis, H. This KH is hydrolysis constant, this degree of hydrolysis. Degree of hydrolysis is going to be Kw divided by Kb multiplied by C, where C is the concentration of the salt, right? In the similar way, what is the pH of the final solution afterwards? pH will be equal to 7 minus half of 7 minus half of. This is the strong acid and weak base, so resulting pH is going to be less than 7. So 7 minus half of, it's going to be P of Kb plus log of C. This is the formula which you are going to remember, by means of which you can calculate pH of the resulting solution. So whenever you see the salt of strong acid and weak base undergoing hydrolysis, these are the three questions which can be asked. Either hydrolysis constant, or degree of hydrolysis, or the pH of the resulting solution, right? In the similar way, my dear people, in the similar way, whenever you see a salt of weak acid and strong base, if the salt of weak acid and strong base undergoes hydrolysis, how do we calculate the hydrolysis constant KH? Now it is going to be Kw divided by Ka, where Ka is the ionization constant or dissociation constant of the weak acid, right? If I ask you what is H, H is going to be under root of Kw divided by Ka multiplied by C. If I ask you what is pH, pH is going to be 7 plus half of, it's going to be P of Ka plus log of C. This is going to be one more result which you need to remember. Whenever the salt of weak acid and weak base undergoes hydrolysis, whenever the salt of weak acid and weak base undergoes hydrolysis, how do we calculate its KH? Its KH is calculated by the formula Kw divided by Ka multiplied by Kb, right? And its H is going to be under root of Kw divided by Ka multiplied by Kb, and its pH is going to be equal to 7 plus half of, it's going to be P of Ka minus P of Kb. These are the direct results which you need to remember, and you can solve the questions in lesser time if you just remember these results. You should be able to identify only one thing, that is the type of salt. That's all, right? Yes? Is it clear to everyone? So let's see now how this sort of question was to be solved. Have a look. I'm removing all these. Calculate the hydrolysis constant. Hydrolysis constant means KH, right? And degree of hydrolysis. And alpha. For NH4Cl, first of all, have a look. NH4Cl, this is the salt which is undergoing hydrolysis, right? Now, first of all, what you need to do exactly, you need to identify the salt. You need to see exactly whether this is the salt of weak acid, strong base, or whatever. And how do we identify it? You have got two types of ions over here, NH4 positive and Cl negative. Can I say NH4 positive would have come from NH4OH? Can I say this Cl negative would have come from HCl? I can say something like that, right? Now NH4OH, it is basically a weak base. HCl is a strong acid. So can I say the salt which I have taken into consideration, it is a salt of weak base and strong acid, right? If it is a salt of weak base and strong acid, how do we calculate its KH? A few minutes back only I gave the formula that was equal to Kw divided by Kb, right? Kw is nothing, that's 10 raised per minus 14, and Kb, dissociation constant of the weak base, that's given to me as 1.8 into 10 raised per minus 5, right? So divided by 1.8 into 10 raised per minus 5. You just need to solve it, get the value of KH, that's all, right? That's all. At the same time, what about the degree of hydrolysis? I gave the formula a few minutes back only. It was Kw divided by Kb multiplied by C. So under root of Kw is 10 raised per minus 14 divided by Kb. Kb is given to me as 1.8 into 10 raised per minus 5. C is the concentration of salt. Check the concentration of salt, which is 0.1. 0.1. Solid, get the value of H, right? And my dear people, in the similar way, what you need to do, you can calculate the pH of the resulting solution as well, right? And pH of the resulting solution, you know the formula, a few minutes back only I gave you. See, the resulting solution, it is weak base and strong acid. So it's going to be 7 minus. 7 minus half of, it's going to be P of Kb plus log of C, right? Do remember, this P stands for minus log. In majority of the question, you will be getting the calculation like this, minus log of 1.8 into 10 raised per minus 5. In majority of the questions, you will be getting the calculation like this, minus log of 1.8 into 10 raised per minus 5. Do remove from now onwards, its value is always equal to 4.74, right? Its value is always equal to 4.74. Do remember directly from now onwards, okay? So pH is nothing, it's going to be equal to 7 minus 1 by 2. P of Kb is directly 4.74 plus log of C. C is the concentration of salt, which is 10 raised per minus 1. Solid, get the value of pH. That's something which you were supposed to calculate, right? I'm sure you can easily solve these sort of questions, which are directly always going to be formula based whenever it is about salt hydrolysis. Perfect? Clear, guys? All right. Have a look on this particular question. Let's understand how this sort of a question is to be solved. And these are the questions which are asked in your examination, my dear people. Just give me a second. Just give me a second. All right, so let's give it a try and let's see how this sort of a question is to be solved. The question says calculate the pH of the solution obtained on mixing 100 ml of 0.1 molar CH3COH with 100 ml of 0.1 molar NaOH. Say exactly how to tackle with this question. So basically, you're mixing CH3COH with NaOH, right? These are the two things which you're mixing. So basically, you're mixing acid with a base. So this is the case of neutralization, you know, when acid reacts with base, it leads to the formation of salt and water. So the salt is going to be CH3CONa, and with this you'll be writing water as well, right? Now, my dear people, the first thing which I'll be doing at time t is equal to 0, I will be calculating the millimoles of acid and base. I will be calculating the millimoles of acid and millimoles of base. How do I calculate the millimoles of acid? Just see one thing. This is the molarity of the acidic solution and this is the volume of the solution. Molarity multiplied by volume of the solution gives us the millimoles of solute. So molarity multiplied by volume of the solution in ml, it gives me the millimoles of CH3COH. So 100 minus 0.1 comes out to be how much? Comes out to be 10. So these are the millimoles of CH3COH which are there in the container at time t is equal to 0. Similarly, how many moles of NaOH are there? 100 multiplied by 0.1. How much it comes out to be? It again comes out to be 10. So again 10 millimoles of NaOH in the container. Since the reaction has not started, so this is 0 and this is also going to be 0, right? Perfect. Now people, these are the millimoles. These are the millimoles of acid and base present in the container at time t is equal to 0, right? Now have a look. Now identify which one is the limiting reagent among the two. Identify which one is the limiting reagent among the two. You are supposed to divide these millimoles by their respective stoichiometry coefficients, right? 10 divided by 1, that comes out to be 10. 10 by 1, that comes out to be 10. So this is the case of complete neutralization. If this is the case of complete neutralization, 0 and 0 will be left. 1 mole gives 1 mole. From 10 millimoles, you get 10 millimoles, right? This will be also 10 millimoles. Now check it out, my dear people. At the end of the reaction, what you're finding in the container, since this reaction is taking place in the container, and at the end of the reaction, what you'll find a salt and water present in the container. Now, what kind of salt is there finally in the container? This is the salt of weak acid and strong base. This is a salt of weak acid and strong base, right? Salt plus water is there in the container. So can I say now they will be undergoing hydrolysis? This is the case of hydrolysis, salt and water is present, right? This is the case of salt hydrolysis, right? And how do we calculate the pH of the resulting solution? When the salt of weak acid and strong base undergoes hydrolysis, it's going to be 7. It's going to be 7 plus half of, it's going to be P of Ka plus log of C. Plus log of C. This is the formula which I'll be using, right? Right, people? Now have a look. Use the formula. It's going to be 7 plus half of. 7 plus half of P of Ka. P stands for minus log. Minus log of this value, you know, that's 4.74. That's 4.74 plus log of C. C is the concentration of salt. Do we know the concentration of salt yet? No. We just know the millimoles of salt. Just divide the millimoles of the salt by the total volume. Just divide the millimoles of the salt by the total volume. Total volume is 100 plus 100, 200, right? So 10 by 200 comes out to be 1 by 20. So this is the concentration of salt. You just need to solve this particular equation and you'll be getting the pH of the resulting solution. Perfect. I'm sure this sort of equation, again, you can solve from now on. Yes? Right, my dear people? Is it clear to everyone? Let me know quickly in the chats. Let me know quickly in the chats if it is clear to everyone so that I can move on. No, Gokul, you cannot do that. That's for hydrolysis. That's for buffer. It's not buffer right now. Just give me a second, guys. All right, so let's move on. Let's move on. This is one more similar type of question. Let's have a look. And see, I've just changed one value over here. I've just changed. Someone is complaining about the stream is running at low FPS. Bro, if you don't want to see it, you can leave, right? Rest, do not just spam it, okay? All right, have a look. I've just changed one value, my dear people, and the overall question will be getting changed. Have a look how. Understand how. Again, what you are doing, you're starting with CH3COH and it's reacting with NaOH. And you know when acid reacts with base, it leads to the formation of salt and water. The salt which you are getting over here, which is CH3CONa, and with this you are getting water as well. This is basically the reaction. This is basically the reaction, right? Number one. Number two, what's the first thing which I'll be doing? I'll be calculating the millimoles of acid and base. How many millimoles of CH3COH are there in the container? Millimoles of CH3COH. Molarity of the solution multiplied by volume of solution in ml. Just multiply the two. 50 into 0.1 comes out to be 5. So these are the millimoles of CH3COH present in the container initially. If I ask you, how many millimoles of NaOH are there in the container? Volume of the solution multiplied by molarity. 100 multiplied by 0.1 comes out to be how much? 10. So 10 millimoles of NaOH are there in the container at time t is equal to 0. This is 0, this is 0, right? Now if I ask you, which one is the limiting reagent among the two? Check it out. 5 divided by 1 is 5. 10 by 1 is 10. So this is having the lesser value, so this one is the limiting reagent, right? This is the limiting reagent. Perfect. If this is the limiting reagent, that means this is the excess reagent. If this is the limiting reagent, there will be 0 millimoles of CH3COH left in the container at the end of the reaction. Now your entire product is decided by the limiting reagent, right? I can say 1 mole gives 1 mole. So from 5 millimoles, you'll be getting some 5 millimoles of this salt, right? Now, since NaOH is the excess reagent, so out of 10 millimoles of NaOH, there will be definitely some millimoles of NaOH which will be left in the container. How do we check that? 1 mole reacts with 1 mole. So from 5 millimoles will be reacting with 5 millimoles of NaOH. Initially, I had some 10 millimoles. Out of 10, 5 have reacted. So I'll be left with 5 millimoles of NaOH at the end of the reaction. Now, my dear people, if I ask you, what is there left in the container at the end of the reaction? Can I say at the end, I can say, just a second. Is there a mistake, guys? Is there any mistake? 100 multiplied by 0.1, that comes out to be 10. This is 5. So this is going to be 0, 5 millimoles of this, right? This is going to be 5, and that's going to be 5. Perfect. Everything is clear, right? Now, my dear people, have a look. What is there in the final solution? Just check it out. What is there in the final solution? The final solution is containing a strong base. The final solution is containing a strong base, NaOH. 5 millimoles of NaOH in the container. So resulting POH as well as pH will be decided by this strong base. It will be decided by this strong base. So if I ask you, now erase everything, I got to know the final pH of the solution will be decided by this strong base, right? So I must say the NaOH which is left in the container, it would have got dissociated as Na positive and OH negative, right? There are some 5 millimoles of strong base which are left in the container. This is 0, this is 0. Now it would have got dissociated completely. So you got the millimoles of OH negative which are finally present in the container, right? Yes. My dear people, if I ask you how many millimoles of OH negative are finally in the container, you will say 5. You will say 5, right? So, but do I need the millimoles of OH negative? No. What do I need then? I need the concentration of OH negative. If I ask you, what is the final OH negative concentration in the container? Millimoles of OH negative divided by total volume. Total volume is how much? 100 plus 50 comes out to be 150. So the value is 1 by 30. Right? This is basically the net OH negative ion concentration in the container. Well, if you got the net OH negative ion concentration in the container, I'm sure you can easily calculate POH now. POH is nothing, it is minus log of OH negative ion concentration, minus log of 1/30. You can solve it, get the POH, and finally you can calculate the pH as 14 minus POH. I'm sure this sort of a question, again, you can easily solve from now on. So what you need to exactly do, you need to see exactly what all things are left in the container finally, right? What all things are left in the container finally. Accordingly, you calculate the pH of the solution. That's all, right? Perfect. I'm sure it's clear. Right, people? All right. A lot of times the questions on solubility product are also asked, right? Let's get to know how to solve the questions on solubility product. The simplest question which I'm starting with. The simplest question, right? Say KSP for MgOH whole 2i. So basically we have got MgOH whole 2i's, right? So first of all, how this MgOH whole 2i's will get dissociated? It will get dissociated like this: Mg di positive aqueous plus 2 times OH negative aqueous, right? Now people, let's assume its solubility is S. This is going to be S. This is going to be 2 times S, right? I just need to write the expression for KSP. It is going to be concentration of Mg di positive raised by stoichiometric coefficient, so S raised by 1. Concentration of OH negative, that's 2S. Raised by stoichiometric coefficient, that's 2. So it comes out to be 4S cubed, right? So I can say S is nothing. S is going to be KSP divided by 4 whole raised to the power 1/3. As simple as that. What is KSP? KSP is given to me as 3.2 into 10 raised power. This is not 14, this is minus 14. It is minus 14 divided by 4. Whole raised power what? Whole raised power 1/3. Perfect. So this value will come out to be 0.8 into 10 raised power minus 14 raised to the power 1/3, which can be written as 8 into 10 raised power minus 15 raised power 1/3, right? So 8 raised power 1/3 is 2 into 10 raised power minus 5. So this is basically the solubility which you are supposed to calculate. That's all, right? That's all. So this is going to be the final answer of the question. That is the solubility in water for this salt. Perfect. Is that clear to everyone? Yes, Sujiram, that is for the acidic buffer. That is for the acidic buffer. Okay. Let me tell you about few things about acidic buffer as well. Just a second. I don't think there is any question added over here as far as the buffer is concerned, but still, let me tell you that. Let me give you certain results. Just a second. Yes, Vasant, I'll be doing that. No issues. I'll be doing that. See, guys, if you talk about acidic buffer, basically, if you talk about acidic buffer, how this acidic buffer looks like, it is basically a mixture of weak acid and salt of the same weak acid with strong base. Whenever in the container you find a weak acid and the salt of same weak acid with strong base, you'll be calling it as the acidic buffer. You'll be calling it as the acidic buffer, right? For example, let's say you have got CH3COH. It's a weak acid. Now you are taking salt of the same weak acid which it has made with a strong base. For example, you are taking CH3CONA, right? This is the weak acid and this is its salt with strong base. So the mixture of the two will be called as acidic buffer. And how do we calculate the pH of the acidic buffer? It's simple. pH is equal to P of Ka plus log of concentration of salt in this particular case divided by concentration of acid in this particular case, right? So this is the general result by means of which you calculate pH, right? Yes? Now similarly, there is one more which you call as the basic buffer. How do we get the basic buffer, my dear people? So if I talk about the basic buffer first of all, basic buffer, what does it contain? Whenever you see a weak base and salt of the same weak base with a strong acid, you call this mixture as the basic buffer. You call this mixture as the basic buffer. Weak base, for example, NH4OH. This is the weak base. Now you are taking the salt of same weak base with a strong acid. For example, you are taking NH4Cl. This is the salt of same weak base with the strong acid, right? So the mixture of the two I'll be calling as basic buffer. For the basic buffer, you calculate POH, and POH is calculated by the formula. It is P of Kb plus log of concentration of salt divided by concentration of base in this particular case, right? So this is how you calculate POH of the basic buffer, and once you get the POH of the basic buffer by using this particular formula, then you can use the formula pH plus POH is equal to 14. From there you can calculate pH, right? Yes? Perfect. Sir, there are some theory questions on buffer solutions. Absolutely, there will be some theory questions based on the buffer solutions. I mean, you just need to identify. You'll begin with a mixture of two substances, right? And you will have to find whether it is an acidic buffer, basic buffer or not. The concept which you will be using, that's something which I gave you. Whenever you see in the container a weak acid and the salt of same weak acid with a strong base, you'll be calling that as the acidic buffer. And whenever in the container you'll find weak base and its salt with strong acid, you'll be calling that as the basic buffer. That is the memory-based theory question which can be asked out of this buffer, right? Or the question can be from the buffer capacity or something like that, right? Perfect. That's something, if you want to see it, that's something which I've taught in detail on this channel itself. You can check it out, right? You can just search buffer solutions by Wasim sir. You'll be getting a lecture of 1 hour in which I've completed this buffer in detail, right? Yes, Orchard, it does not, significantly change the pH. Perfect. So is every single thing clear till here? So with this, your equilibrium is done and dusted, right? So which questions you want me to do, which you want me to solve now? Do you want me to solve the questions of kinetics first or thermodynamics? Do you want me to solve the questions of kinetics or thermodynamics? Let me know fast. Kinetics or thermodynamics? Let me know in the chats. Fast. Kinetics or thermodynamics? See, 2 chapters are done so far, chemical and ionic. Which you want me to do the next? Do you want me to solve the questions of thermodynamics or kinetics? Fast. Fast, people. Rihan, maybe I might be looking dull today because yesterday I've taken a very long marathon of 11 hours, right? I started the session at 2 and ended up at 12:30 or 1, something like that. So I'm still tired. So yesterday was a hectic day, right? I was not in a position basically to take this session also today, but I had promised you, so that's the point of coming here. All right, majority of the students are saying thermodynamics. So let's try to do the questions of thermodynamics first. After that, we shall be doing the kinetics questions, right? Perfect. Let's start with the questions of thermodynamics. And these are the questions which you should be able to solve now. And I'll be little fast now. At STP, following reactions are given. Identify in which reaction work is done by the system or on the system. First thing, you guys must be knowing, whenever there is expansion, we always say work is done by the system, and whenever work is done by the system, W value is taken to be negative as per sign conventions, right? Number 1. Number 2, whenever there is compression, we always say work is done on the system, and whenever work is done on the system, W value is taken to be positive as per sign conventions in chemistry, right? Now, look at the first reaction, my dear people. On reactant side, you have got 7 plus 4, 11 moles. On product side, you have got 6 plus 4, 10 moles. On reactant side, 11 moles. On product side, 10 moles. So when the reaction is happening, are the number of moles increasing or decreasing? Number of moles are decreasing. Number of moles are decreasing, right? Since all the reactions, they are taking place at STP. That means pressure and temperature is constant. And you know, when pressure and temperature is constant, I must say volume is directly proportional to number of moles, right? Since when this reaction is proceeding, number of moles are decreased, more volume than the liquid water due to a special cage-like structure. I hope you know that, right? Ice into liquid water. More volume, less volume. More volume to less volume. That means compression. W value positive, right? Solid getting converted into gas. Expansion. Volume is increasing. Expansion, right? Expansion. So W value is going to be negative. During expansion, W value is taken to be negative. As simple as that, right? Yes? Perfect. For KMnO4 in acidic medium, you will be taking its N factor as 5. And for K2Cr2O7 in acidic medium, you will be taking its N factor as 6, right? Perfect. Look at this one, guys. A very simple question. A system expands from 5 liters to 10 liters. A system expands from 5 liters to 10 liters against constant external pressure. Whenever you see this statement written, constant external pressure, take the process to be irreversible. Take the process to be irreversible. Whenever you see in a question, a statement mentioned that against a constant external pressure, so take the process as the irreversible. A system expands from 5 liters to 10 liters. So initial volume of the gas is 5 liters, final volume of the gas is 10 liters. External pressure, that is 2 atm. What do you need to calculate? If the system absorbs 800 joules of heat, so Q value is plus 800 because system is absorbing heat. Whenever system absorbs heat, Q value is taken to be positive. Calculate the value of delta U. Use the first law of thermodynamics. Delta U is equal to Q plus W, right? And this is W irreversible over here. Now, if I ask you what is W irreversible? W irreversible is nothing. It is minus P external delta V, which is V2 minus V1, minus times P external is given to me, how much? P external is given to me as 2 atm, V2 minus V1. So 10 minus 5 comes out to be 5. So the value is going to be minus 10 atm liter. Minus 10 atm liter. So convert it into joules. So minus 10 multiplied by 101.3 joules, right? This is the value of W in joules. Perfect. So delta U is nothing. It is going to be Q plus W. Q is 800 joules. W is minus 1013 joules, right? So the value finally will be minus 203 joules. This is the value of delta U, which you were supposed to calculate, right? Simple and basic. I'm sure you got to know how to solve this. Simple. Right, people? Delta U is equal to Q plus W. Perfect. W I have calculated in joules. Put it over here in the first law. Get the value of delta U. That's all. Moving on. 1 mole of ideal gas undergoes a change in state. So you have got the ideal gas whose initial state parameters initially were 2 atm and 3 liters and final state parameters are 2 atm and 7 liters. See, since the state of the system is changing, but if you see, the pressure of the system is not changing. So what is the formula which I should be using over here? I should be using a simple formula. Delta H is equal to delta U plus P delta V. This is the formula which I'll be using since the pressure of the system is kept constant. So delta H is going to be equal to delta U. Delta U is 30 atm liter plus P. P is 2 atm. V2 minus V1. 7 minus 3 comes out to be 4. 8 atm liter. So value comes out to be at the end 38 atm liter. This is the value of delta H which you were supposed to calculate. That's all. This is the value of delta H which you were supposed to calculate. Perfect. One more question. This is the reaction that's given to me. We need to calculate delta U for the reaction. First of all, I'll be calculating delta Ng for the reaction. Delta Ng for the reaction is equal to number of moles of gaseous products, that's 1, minus number of moles of gaseous reactants. So delta Ng value is equal to 1. If delta Ng is equal to 1, I'll be using the relation delta H is equal to delta U plus delta Ng RT, right? So from here, you'll be calculating delta U, which will be delta H minus delta Ng RT. Well, people, is the value of delta H given to us? Yes. Delta H value is 40.66 kilojoules, right? Minus delta Ng value is 1. R value is 8.314. Temperature is given to me as 100 degrees centigrade, 373. At the same time, since this term is in kilojoules, so this whole term has to be in kilojoules as well. Since I've used the value of R as 8.314 joules per Kelvin per mole, so I'll be dividing simultaneously with 1000 so that this term also comes in kilojoules, right? And when you solve this, the value comes out to be 37.5. 37.5 kilojoules is the value of delta U. But this is not the answer of the question. Why is that? Let me tell you, this is the value of delta U when we vaporize 1 mole of liquid water. This is the value of delta U for the vaporization of 1 mole of liquid water. But as for the question, we are vaporizing 2 moles of liquid water. For the vaporization of 1 mole of liquid water, delta U is this much. For the vaporization of 2 moles of liquid water, multiply this term by 2. So the final answer will be 75.1 kilojoules, right? Do remember it from now onwards. All right, one more question. Calculate delta H for the reaction. Since the reaction is given to us, we need to calculate its delta H. You know the formula already. Delta H is equal to delta U plus delta Ng RT, right? Now, first of all, I need to calculate delta Ng for the reaction, which is going to be equal to number of moles of gaseous products, 1 plus 1, that's 2, minus number of moles of gaseous reactant, that is 3 by 2. So the value comes out to be 1 by 2. This is delta Ng. Since you calculate delta Ng, so the value of delta H is going to be delta U. Delta U is given to us as per the question, minus 742.7, but this is in kilojoules, right? Plus delta Ng value is 1 by 2. R value I shall be using as 8.314 joules per Kelvin per mole. Temperature is given to be as 298 Kelvin. Let me tell you, the units of this whole term will be right now in joules, so divide it with 1000, right? So that this comes in kilojoules per mole as well. So now add them up and get the value of delta H from here. That's something which you are supposed to calculate. As simple as that, right? Perfect. Let me show you the final answer of the question. It will be something like this, right? And the answer will be negative. It is minus times 741.46. Do remember it. One more question. Calculate delta U and delta H when 10 decimeter cube of helium. So basically 10 decimeter cube means 10 liters. So basically you have got 10 liters of helium at STP. You have got 10 liters of helium at STP. If I ask you how many moles of helium do we have, you will say 10 liters divided by 22.4. These are the moles of helium which you have, right, at STP. Now, since the helium initially was at STP, that means the initial temperature of helium is supposed to be 0 degrees centigrade. Now you are heating this helium to the final temperature of 100 degrees centigrade. What do we need to calculate? We need to calculate delta U and delta H. So first of all, I'm assuming the helium is over here as the ideal gas. So for the ideal gas, delta U is equal to NCV delta T, and for the ideal gas, delta H is equal to NCP delta T. I hope you know that, right? Now people, so delta U is equal to N. How many moles? 10 divided by 22.4. CV value. Since helium is a monoatomic gas, so it's going to be 3 by 2R. Delta T is change in temperature. Change in temperature is simple 100. Final minus initial, right? Similarly, delta H, it's equal to N. N is nothing, 10 divided by 22.4. CP is for the monoatomic gas, 5 by 2R. Delta T is nothing, that's change in temperature 100, right? Now, you just need to put the value of R depending on the question. If the answer is asked in joules, so put the value of R as 8.314. If the answer is asked in calories, put the value of R as 2 calories per Kelvin per mole, right, etc., etc. In the similar way, this one and this one is to be solved. You'll be calculating delta H and delta U for the gas which you are supposed to calculate, right? Okay. Calculate the work done in complete decomposition of 5 moles of PCl5. So basically, you are decomposing 5 moles of PCl5. You need to calculate work done. I'm sure you know this particular formula. W is equal to minus delta Ng RT, right? So first thing, I'll be calculating delta Ng for the reaction, which is number of moles of gaseous products, 1 plus 1, 2, minus number of moles of gaseous reactant, which is 1. So delta Ng value is 1, right? Since if you got the value of delta Ng, so W value is equal to minus times delta Ng is 1. R value I'm taking in calories. Temperature is given to me as how much? Temperature is given to me as 300 Kelvin. So the value comes out to be minus 600 calories, right? Yes. So this is the value of W. But do remember, this is the value of W for the decomposition of 1 mole of PCl5. But I'm doing the decomposition of 5 moles of PCl5. So work done for the decomposition of 5 moles of PCl5 is going to be minus 600 multiplied by 5. So the answer is going to be minus 3000 calories. So this is the value of work done, right? This is the value of work done during the decomposition of 5 moles of PCl5, right? This was the work done for the decomposition of 1 mole of PCl5. Now this is the work done for the decomposition of 5 moles of PCl5. I'm sure this is clear. Similar sort of question. 5 moles of N2H4 undergoes decomposition. Calculate the work. So first of all, again, I'll be using the result minus delta Ng RT. Now first thing which you'll be doing over here, you'll be calculating delta Ng value. Delta Ng is number of moles of gaseous products, 4 plus 1, that's 5. Minus number of moles of gaseous reactant, that's 0. So delta Ng is 5. If delta Ng is 5, calculate the value of W, which is equal to minus times delta Ng is 5. R is 2 calories per Kelvin per mole and temperature is 300 Kelvin, right? So the value comes out to be W is equal to minus 3000 calories. Minus 3000 calories. This is the value of W for the decomposition of 3 moles of N2H4. When we decompose 3 moles of N2H4, W value is minus 3000 calories. When we decompose 1 mole of N2H4, it's going to be minus 1000 calories. But right now we are decomposing 5 moles of N2H4, so it's going to be minus 5000 calories, right? So this is the value of W, which you are supposed to calculate. That's the answer. Perfect. I'm sure this is clear. So minus 5000 is going to be the correct answer of the question. Perfect, guys? Right? Absolutely. What does this minus signify over here? That means work is done by the system, right? I hope you know that. Perfectly done. Moving on to one more. Calculate Q, W, delta U and delta H when 2 moles of an ideal gas. Have a look. You're starting with 2 moles of ideal gas, right? So N value is 2. 2 moles of ideal gas. Expanded reversibly and isothermally. expanded reversibly and isothermally from initial pressure of 10 atm. So initial pressure of the gas is 10 atm, final pressure of the gas is 5 atm, and temperature of the gas is kept as 27 degrees centigrade, matlab 300 Kelvin, right? What do we need to calculate? We need to calculate Q, W, delta U and delta H. Since the process is isothermal, right? You know, whenever the ideal gas undergoes isothermal process, its delta U as well as delta H both are taken to be 0. I hope you know that. Whenever the ideal gas undergoes isothermal process, its delta U as well as delta H, both the terms are taken as 0. Perfect. Now, since delta U is 0, delta H is 0, two things are done, right? Since delta U is equal to 0, delta U is equal to Q plus W, so that means Q plus W is 0, that means Q is equal to minus W. So in order to calculate Q, I need to get the value of W. Since the process is reversible, and how do we calculate work done in reversible isothermal expansion? It's equal to minus nRT ln of P1 by P2. Ln of P1 by P2. So work done in reversible isothermal process is equal to minus. N value is given to me as 2. R value, I'll be taking calories for example. Do we have to get the value of all these things calories? Yes. R value calories, 2 calories per calorie per mole. Temperature is given to me as how much? 27 degrees centigrade, that means 300 Kelvin. It's going to be ln of P1 by P2. P1 is 10, P2 is 5, 10 by 2 is 10 by 5 is 2. Ln of 2, as per the question, is given to me as 0.7. So instead of this thing, I'll be writing 0.7 over here. And when you solve this, you get the value as minus 840 calories. So this is the value of W which you got. Since you got the value of W as minus 840, that means Q value you'll be getting as plus 840 calories. As simple as that. So all the parameters you have calculated, Q, you have calculated, W calculated, delta U and delta H, all the things are calculated, right? Simple and basic. Perfect. I'm sure you can easily solve these sort of questions from now onwards. Just remember the result, use the result and solve it. Perfect. All right, which of the following is correct option for the free expansion of the ideal gas under adiabatic conditions? First of all, he's talking about free expansion. For free expansion, W value is 0, right? Free expansion, W value is 0, number 1. Since it's adiabatic as well, so Q value is also 0, since it's adiabatic, right? W is 0, Q is 0. That means delta U is equal to Q plus W. Since Q is 0, W is 0, so delta U is 0. What is delta U? Delta U for the ideal gas is NCV delta T. That means NCV delta T is 0, right? That tells me delta T should be equal to 0. That tells me temperature should be constant. If temperature is constant, the process is supposed to be isothermal as well, right? So the question is done. You can follow the question. Everything is done. See, W is 0, Q is 0, delta T is 0, T is constant. Check the options. Option C is the one which is correct, right? Right, guys? I'm sure this again clear to everyone. Perfect. All right, look at this particular question. A sample of fluorocarbon was allowed to expand reversibly and adiabatically. A sample of fluorocarbon is allowed to expand reversibly and adiabatically. So the process is reversibly adiabatic. The process is reversibly adiabatic to twice of its volume. Let's say initial volume of the gas was V, final volume of the gas is, for example, 2 times V now. In the expansion, the temperature dropped from initial temperature of the gas was 400 Kelvin. Now the final temperature of the gas is given to me as 100 Kelvin. Right? 100 Kelvin. Assuming ideal gas conditions, calculate CV for the gas. Since I need to calculate molar heat capacity at constant volume for the gas. CV is nothing, that's equal to R divided by gamma minus 1, right? Since the process is reversible adiabatic, for the reversible adiabatic processes, we can use the equation T1 V1 raised by gamma minus 1 is equal T2 V2 raised by gamma minus 1, right? T1 value is given to me as 400, V1 is nothing, that's V raised by gamma minus 1, T2 is given to me as 100, V2 is 2 times V raised by gamma minus 1, so double zero cancel, it's 4, V raised by gamma minus 1, V raised by gamma minus 1 cancel, so on the right hand side you will be having only 2 raised by gamma minus 1, 4 you can write 2 square, that means gamma minus 1 is equal to 2. Gamma minus 1 is equal to 2. If gamma minus 1 is equal to 2, I can say CV is equal to R divided by gamma minus 1, that is 2. So R by 2 is the final answer of the question. I'm sure you can easily solve this question as well. Perfect. Right? Okay. We need to see the value of delta S. If the entropy change is positive, negative or whatever. Have a look. In the first reaction, on over here stoichiometric coefficient is 1, right here 2. So when the reaction proceeds, number of moles are increasing. 1, 2. When the reaction proceeds, number of moles are increasing. If the number of moles is increasing, that means number of particles are increasing. And if the number of particles are increasing, that means disorder is increasing. If the disorder is increasing, that means entropy is increasing. If the entropy is increasing, delta S value should be positive. Solid into gas, disorder will be increasing. Entropy increasing, delta S positive. Diamond into graphite. Diamond is less disordered, This one is more disordered, right? Less disorder to more disorder. Entropy increasing, delta S positive. This is half over here. On the reactant side, 1 plus 1 by 2, total 3 by 2 moles. On the product side, 1 mole. So on the reactant side, 3 by 2 moles. From 3 by 2 moles to 1 mole. So number of moles are decreasing, number of particles are decreasing, disorder is decreasing, entropy is decreasing, delta S negative. Liquid into solid, disorder is decreasing, delta S negative. On the reactant side, you have got gases. On the product side, you have got solid. So gases are getting converted to solid, right? So disorder will be decreasing, delta S negative, right? Right, I'm sure you can easily solve this sort of question as well. Perfect. Is it clear, guys? Right? You should be able to solve these questions. Wait, this question we solved 5 minutes back only, and its options are irrelevant. Leave this question aside, guys. This question, CV for the gas, we got to know as R by 2. R by 2 was its answer, right? Perfect. Right? These are the options of some other question, right? These are not the correct options. These are not the correct options, right? This is some other question in which you have to calculate entropy change, and the question is given here. Anyways, leave it. Okay, for a given reaction, delta H is given, delta S is given. The reaction will be spontaneous at. See, for the process to be spontaneous, delta G for the system at constant pressure and temperature, it has to be less than 0, right? It has to be less than 0. Then only we can say the process spontaneous. Perfect. Now delta G. Delta G is nothing, that's delta H minus T delta S, right? Yes, that is less than 0. Now guys, I must say delta H has to be less than T delta S, or I can say T delta S has to be greater than delta H, or you can say temperature has to be greater than delta H divided by delta S, right? Then only the process will be spontaneous, right? Delta H value is given to us as 35.5 kilojoules per mole. So delta H is 35.5 into 10 raised power 3 joules per mole divided by delta S is given to me as 83.6 joules per Kelvin. Just solve this and get the value of temperature in Kelvin, right? So the temperature has to be greater than this particular value. Then only I must say the reaction is spontaneous, right? Perfect. So the final answer of the question will be 425. After solving this particular term, you'll be getting 425. So the temperature has to be greater than 425 Kelvin. Then only we can say the process spontaneous, right? Yes, as simple as that. Darshini, you cannot find it like this, right? A reaction should be given to you, then only you can say. Perfect. So these were the questions from the chapter Thermodynamics. Now I think electrochemistry questions I'll be doing in the next session, right? Perfect. Electrochemistry questions I shall be doing in the next session, right? Perfect, guys. So at the end, if you have not liked the video, please do like the video, share the video with your friends, and do subscribe to the channel as well. Perfect. And at the same time, if you are looking for the test series, Vedantu has launched a new and fresh test series which contains 10 tests, my dear people, right? And that test series is completely of the level of your NEET 2022 examination, right? That is absolutely of the test series which Vedantu has come up with. Let me tell you, that is completely based on the NEET 2022 pattern, right? Whatever is going to be the NEET 2022 examination, similar sort of questions you'll find out in this particular test series, right? Perfect. NEET 2022 test series, you need to click on this. After click on this, you'll be directed to one more page. You need to click on buy now. In just $9.99, you'll be getting some 10 tests, my dear people, right? Which you can solve in these last 10 days, by means of which you will be getting the idea of the level of the examination, which is going to be happening in a couple of more days, right? Yes, you can get it. This is just $9.99, which is completely affordable. Get it, my personal suggestion, because it is one of the finest test series which has been designed by the best teachers of the country, right? Do get it. It will be helpful for you for these last days. Perfect. So with this, I'll be taking a leave. I'll see you guys tomorrow at the same time, right? Tomorrow at 8 p.m. I'll see you. Perfect. Till then, you take care. Bye-bye. God bless you all. Love you all. And if you have not liked the video yet, please do like the video. Share the video with all of your friends and do subscribe to the channel as well. Take care, guys. God bless you all. Bye. Yes, Anjali, I'll be doing that.